Welcome to the section number 6. In this section, we will learn how to create communication that is robust between containers and microservices that are working within containers managed by Kubernetes. So firstly, we'll be understanding problem of service discovery in distributed environment. So we'll see how can we achieve service discovery and why the problem exists in the first place. Video number 2 will be about leveraging service object to get the state of the specific service. So we'll interact with a specific service definition by the Kubernetes API. In the video number 3, we'll see how we can do manual service discovery for more advanced mechanism. So sometimes if you want to have third-party solution and use service discovery that's not embedded with Kubernetes but other library, we can leverage that mechanism. Finally, we'll be using cluster IP environment variables. This is the first video in which we will be understanding problem of service discovery in distributed environment. So we'll answer the question what is a service discovery and solve the problem with level of indirection. So we'll create basically a proxy that serves a purpose of discovering other instances. Finally, we'll be looking at the Kubernetes service discovery pattern with labels. So how to discover pods in Kubernetes. So you can see that in this Kubernetes setup, we have couple independent namespaces, setups, clusters, and within them there are some pods. So for example, service B is exposed in 2 clusters and has 2 services, and service 1 has 1 pod and service 2 has 2 pods. Service A at the downside of this diagram has only 1 pod. And we have a deployment that consists of the service A and B. You can see that there is a lot going on. Every service has different IP and everything could be dynamic. So for example, you may want to add a new instance to a service A and the IP will be accessed and assigned dynamically. So you need to propagate that information somehow in the environment because let's say service B needs to speak with service A, and if there is a new instance of service A, we want that instance to take some traffic from service B. We don't want to make that instance to sit idle. So how to solve that? So there is a generic pattern that is called service discovery. We can leverage that pattern to solve the problem. So imagine that we have 3 services. Service with instance A, service instance B, and service instance C. So 3 instances of the same service or 3 different services. It doesn't matter here. At the left hand side we have service client. It could be a different microservice that needs to execute requests to the service instance A, B, or C. He wants to get a response for his request, but he doesn't know service client where those services are. So it doesn't know an exact IP because IPs could be assigned dynamically. So how to do it? So service client could query for service, and there is a service discovery that is a level of indirection. This is our proxy. So when the service instance A, B, or C is starting, or if you are adding instance D, every instance, first thing that it is doing is to register itself in a service registry. So it gives us IP, and service registry is remembering IP for the service. Then when service client wants to get the lookup of the specific service, the service registry can decide which instance to return, and also it can return some kind of load balancing. So this is a pattern used to service discovery.